All right, hello, my wonderful students. This is part number 3, foldable number 2. So for this one, we're going to be doing, it looks like it's going to be a rhombus, because it says rhombus, but it's still find the perimeter and area of each. So we're going to go ahead and plot our points, and then we're going to kind of find the area, and then find our perimeter. All right, so first things first, we're going to go ahead and plot our points. So we have, -3, -2. So we have 1, 2, 3, -2. Then we have our -2, 2. Oh, sorry, this is A. -2, +2, or B. 2, +3, or C. And 1, -1, which is our D. So I'm going to go ahead and draw these out. I haven't done one in red. I'm going to do this one in red. And this is a rhombus, which means that all the sides are the same length. But in order to find the area, we actually have to find the diagonals, which is, we'll do one blue, we'll do one green, so we'll have, because the area for this, if you guys remember, area for a rhombus and a kite is 1/2 times diagonal 1 times diagonal 2. So D1, D2. So we can go ahead and do each of these in different color, and it's going to be based off of the points and how we find the distance. All right, so we're actually going to be using the distance formula on here twice. So if you guys remember, the distance formula was x1 plus x. Sorry, I think I'm losing my voice a little bit. Sorry. All right, so the distance formula is the square root of x2 minus x1 squared plus under the same square root of y2 minus y1. We'll actually just write it in as well. So distance formula here is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so in order to do that, we're going to use B and D, and I'm going to go ahead and use my B as our x2s, or our 2s anyway. So this is going to be our x2, it's going to be our y2, and then our D is going to be our x1 and our y1. We have to make sure that when we do this, we keep it the same, because if we mix this up, say like we use this as our x2, and then this is our y2, it's not going to give us a proper distance. So we're going to do this one in blue, since this line is blue. So our D is going to be equal to the square root of x2, which is -2, minus our x1, which is 1 squared, plus our y2, which is 2, minus our y1, which is -1 squared as well. -2 minus -1 is equal to -3 squared, plus 2 minus a -1 is also equal to 3 squared. So we have 3 squared, which is equal to 9 plus 9. So it's going to be the square root of 18. 18, or 3 radical 2. So we see that the distance here is 3 radical 2. Perfect. And now we're going to go ahead and find our distance for the next one here. We have the distance is equal to, we have to assign our variables, right? So for this one, we have A and C. I'm going to go ahead and use A as our x2 and our y2, and C is our x1, y1. So we have the square root of x2, which is our -3, minus our x1, which is 2 squared, plus our y2, which is -2, minus our y1, which is 3 squared. Oh, they all kind of worked out. Well, I guess, yeah, it has to work out nice, right? Because they are the same. Because this is also the same as this. And this is also the same as this. All right, but I digress. So we have negative 3 minus 2 would give us a negative 5 squared. Oh, get that parentheses because of negative. Added to our negative 5 squared. And negative 5 squared is 25. So we have 25 plus 25. And we end up getting a wonderful square root of 50, which is equal to 5 radical 2, which is good because when we multiply these together, we're going to get a nice even number. So now to find our area, we're just going to take our area here. Oh, it's not the same A, so I should do it in red. Area here, remember, was equal to our 1/2 times our D1 and D2. So our D1 was, I should do D1, and this is our D2. So we're going to have 1/2 times our D1, which was 3 radical 2, times our D2, which was 5 radical 2. All right, now to do that, we're just going to multiply this here first. So we have 3 times 5 is, so still 1/2, times 15. Radical 2 times radical 2 would give you radical 4, which is 2. So it's going to be times 2. But if you're taking the half of something and multiplying it by 2, it's the same thing you saying 1/2 times 2 is 1. So this is going to equal to 15. So the area of the rhombus is 15. And you know what? There's already enough work on here. We're not going to be able to find the perimeter. I guess I should have left an old space 1 per. So I guess we're just going to like pretend this never said perimeter here. And we're going to just focus on the area for this one and the kite. But it's the same thing. It's just like you found the distance from here to here. You would find the distance from here to here and then multiply that by 4 because all 4 sides are the same to get the perimeter.